This video serves as a technical overview for our Mechanical Engineering Senior Project, RSVP Spaceship.
The project was to design and build a spaceship prop to be used during this year's RSVP performance. The following are the main design constraints for our project, but for more of an overview, we hope that you view our other video, RSVP Spaceship and Introduction.
After fully defining the problem and doing some background research, our team spent a great deal of time ideating. Through our ideation process, we generated hundreds of spaceship ideas, but ultimately narrowed it down to these top 8, shown here in our weighted decision matrix, in which ideas 1 and 5 proved to be the top designs. Our final design incorporates the best concepts from our weighted decision matrix and is broken down into 5 subsystems, including the rolling pilot seat, top hatch, rear entry hatch and thrusters, fuselage with fixed wings, and a guitar compartment.
This image shows how the pilot will load into the spaceship from underneath the stage. The top figure shows the unloaded position with the pilot seat back behind the ship, and the bottom figure shows the ship ready to roll onto stage with the pilot loaded and the rear hatch closed. We opted to construct the fuselage frame out of square wooden dowels for the main structure and MDF sheets to create the curved profiles, as shown on the right. After constructing the frame, we would use chicken wire and a mesh thermoplastic to create the exterior shell, as shown on the left. Finally, the front includes a form-fitted padding for the guitar. The top 2 figures give an idea of how our 4-bar mechanism would lift our top hatch. Once the hatch was opened, the actor would stand up and exit the ship from either side. The top hatch would be manufactured in a similar manner as the fuselage, but would instead use aluminum strips to create the desired spaceship curves, as shown on the bottom left, and a tinted transparent thermoplastic for the windshield to add an element of mystery, as shown on the bottom right. We chose to use MDF for the rear hatch so that we could create the necessary curved profile. The gate latch was used to lock the door in place once the actor was loaded in, but it also serves as a part of our emergency egress mechanism, as the actor can pull a lever to release it and open the hatch in case an emergency exit is required. The thrusters themselves are made out of 2 found shapes from Home Depot.
And speaking of thrusters, to create that thruster smoke effect, we would use piping running along the inside of the ship to pipe fog from the fog machine stowed in the front to the rear thrusters. This would be done using PVC pipe and flexible tubing.
And finally, the guitar hatch would be actuated by gas springs, as shown here. The shell would be made out of a combination of aluminum and mesh thermoplastic.
Shown here is the entirety of the manufacturing we were able to complete. So as you can see, the top hatch, fuselage, and pilot seat are coming together in both an open and closed position.
We sought out to verify that our final product met all of our design specifications through this verification plan. Some preliminary tests were conducted to assess the thermoplastic surface finish. Next, we verified our internal dimensions and ensured minimal deflection for a 150-pound load. We also planned test work for our finished product, however these tests were not performed. They included verifying external dimensions, quantifying the timing of deployment and egress, quantifying decibel sound, ensuring the prop did not snag on anything, and determining the deflection of the thermoplastic shell for various loads. Due to the impact of the COVID-19 pandemic, our team came up with an alternative end to this project. We created an engineer's guide to making a theatrical prop on Instructables that takes all we had learned thus far and transforms it into a resource for anyone needing to create a prop similar to ours. And this concludes our technical overview. Thank you for listening.